This video experiment will demonstrate the reaction of acid with carbonate samples in order to determine the percent carbonate. Many times it is difficult to test for a compound directly. Therefore, it is reacted in order to detect one of the products. In this case, carbonate, which is an ion and difficult to measure, is reacted with hydrochloric acid. The product of this reaction is carbon dioxide gas. The gas carbon dioxide bubbles away, therefore the mass of sample after the reaction is less than the mass beforehand. This difference in mass is the mass of carbon dioxide. Based on the molecular weight, we can determine how many moles of carbon dioxide gas bubbled out of the sample, and then convert that to moles of carbonate, and finally into grams of carbonate. Based on the sample mass, you can determine what is the percentage carbonate for the sample. The first sample looks at the percent carbonate found in baking soda or sodium bicarbonate. The experiments are performed in small vials, and the masses are recorded using digital analytical balances. These balances have significance to 4 significant figures and can detect very small changes in mass due to the loss of carbon dioxide. In the experiments, all of the mass is accounted for, including the mass of the liquid hydrochloric acid. The hydrochloric acid is drawn up into a small micropipette, and the beginning mass is the mass of the micropipette, beaker, and empty vial. The recorded mass of the empty beaker, empty vial, and hydrochloric acid can be seen here. With the empty mass recorded, a small amount of carbonate sample can be placed in the vial. The mass of which can be measured in the second weighing. The recorded mass of the beaker, vial, hydrochloric acid, and the carbonate sample can be seen here. This is the mass of the sample before the reaction. After the reaction, the mass should decrease based on the loss of carbon dioxide. When performing chemical reactions, it is important that they are performed carefully and correctly. In this example, adding hydrochloric acid too fast can cause the reaction to violently release too much carbon dioxide and spill out of the vial. This would make for a loss of product and an inaccurate reading in the percent carbonate. After recording the mass, the acid is reacted with the carbonate sample. This is done slowly to allow the gas to escape without overflowing the vial. When the reaction is finished, the sample can be mixed to ensure that all of the reaction is finished, and everything is reweighed in the last portion of the experiment to account for all mass, including the empty pipette. The mass of the beaker, vial, acid, and sample after the reaction can be seen here. The difference between before and after the reaction is the mass loss of carbon dioxide. This can be converted to a mass of carbonate by using the molecular weights for carbon dioxide and carbonate. Based on the mass of the total sample, you can then figure out what is the percent carbonate in baking soda. In the second reaction, we will look at the reaction of baking powder with hydrochloric acid. Baking powder is a blend of sodium aluminum sulfate, calcium phosphate, cornstarch, and baking soda. From the reaction, we can get not only the percent carbonate that's found in baking powder, but also what percentage of baking powder is made up of baking soda. Baking soda is the only component of baking powder that will react with hydrochloric acid to form carbon dioxide gas. As with the baking soda sample, the first mass to record is the mass of the empty beaker, an empty vial, and a pipette filled with hydrochloric acid. The combined mass of these three items is seen here. This is the starting mass in the calculations. Approximately a 0.5 gram sample of baking powder is added to the vial. The mass of which is then recorded. The combined mass of the empty containers, the acid, and the baking powder sample can be seen here. This is the mass before the reaction takes place. The acid is slowly reacting with the baking soda within the baking powder. This reaction is releasing carbon dioxide gas. You can already visibly see that there is less reaction taking place with the baking powder, indicating that there is overall less baking soda than 100%. After the reaction is complete, the combined mass of everything can be weighed again. The mass difference before and after the reaction is the mass loss of carbon dioxide. The mass after the reaction is seen here. It is this reaction with acid that allows both baking soda and baking powder to be used as leavening agents when baking.